in pump design, this is the example for pump design. In design of pumping station with the following data for the pump and rising main, determine whether the pump can lift discharge of 500 liters per second to a height of 35 meter static head. What's given here is we have a pumping station and static head required for this pumping station is 35 meter. This is the rising main, the flow rates and the losses, pump characteristic, flow rates, and pump head efficiency, and also the efficiency. So this is the flow rate, this is the pumping head, and this is the efficiency. Now, how can we answer this question whether for these characteristics of the rising main and if the pumping characteristics, if the pump can achieve this goal of 500 liters per second to a height of 35 meter static head. Now, the solution. Here, analysis and design. Here, we started the solution. Now, this one is the same as before, except that in this table, we have produced a new table in which there is a total head. So we produce this one, the rising main characteristic with flow rate, losses, and this is the total head required for this pump. You see, it is exactly this table with the third line here in red. Now, what we are going to do is to graph the flow rate, this one, a graph here, it is the same as before, just we are going to graph these relationships. So now rising main. Now the blue line, this is the blue line. The blue line is this one. So the blue line is the graph of this one. This one. So these two gives this graph, the blue one. Oh, okay. Now the green graph, it is the pump characteristics, which is the flow rate and pump head. So this is the green line. And the red one is the efficiency. The red line is, the red graph is this one, is the efficiency with the head. So these two, you see, on the x-axis, it is the flow rate, while on the vertical direction, vertical axis, it is the head, the total head. Now, these are the graphs. I'll find at this point of intersection, it is this one, between the pump graph and the rising main. So from this intersection point, you see, this is around 0.43 meter cube per second. And now for 40 meter. So now for this pump, the question is whether it can achieve 500 liters per second for a height of 500 meters. Here it is 0.43 meter cube per second, which equals to 430 liter per second. And this one is less than 500 liter per second required in the question. So this pump cannot achieve the performance we required. Now also we can find the efficiency of this pump at this point, which is around 36%. So this is, we have just answered, or we have just designed and analyzed the pump for this requirement, and we found that it is inadequate.